Hello everyone, welcome to the Murphy Virtual. Hope you are doing good. Today I'm going to continue with chapter number 3, that is machine level representation of programs, and the topic is same, arrays, that is array allocation and access. In the yesterday's class we discussed a little about the arrays, means what is array, how we can define the array. So today I'm going to continue with array only, but first let's take a quick review or the quick recap of the last class, that is yesterday's class. So let's take a quick review. In the last class we discussed the array. What is array? Array is a combination of similar data types. So whenever we combine the digits or the numbers that have a similar data type, that is known as array. So array provides a data structure known as array, or C provides a data structure known as array that is used to store a fixed size sequential collection of elements of the same type. This says store a fixed size sequential collection. Fixed size means there is a fixed size of the array, for example array 5 that contains 5 values from 0 to 4 of the same type. Same type means of similar data type, that is if int, so all the values are of int type. If double, then all the values are of double type. Then we also talked about how we can initialize the array. This is your index, that is first element is your number 0, then number 1, number 2, number 3 and so on till last element. Next part is how to declare the array. This is type, array name, array size. Type means data type, it may be int, it may be float, it may be double, it may be char. Then there is the array name, means the name of the array, then the array size. Array size is denoted in square bracket, not in curly braces but in square bracket. For example, int or double balance 10, that is balance is a variable array which is sufficient to hold up to 10 double number. So the type is double and the array name is balance and the array size is 10. This is the way how we can initialize the array, that is double balance 5 1000.0. Why there is a decimal part? Because I am using double in a data type. So this is a double type, that is 1000.0, 2.0, 3.4, 17.0 and 5.0. Sorry, 50.0. This says the number of values between braces cannot be larger than the number of elements that we declare array within the square brackets. Means the array elements should not be greater than the what we declare in the array declaration. And the vice versa is not true. Means if I declare 5 and I am giving only 4 elements, then it's okay. Means the number or the declaration is not more than the elements what we give in the definition or declaration. Then one important thing is that array elements always start with the 0. Means if there are 5 elements, so it starts with 0 and ends with the 4. It goes from 0 to 4. So in this example, if I want to find balance 4, that is your 50, that is your at 5th location, but it starts from 0, it is from 0 to 4, that is your 50. Then we also discussed how we can access the array elements. An element can be accessed by using the array name. This is done by placing the index of the elements within the square bracket. This is the way how we can access the element. Means the balance 9 means at the 10th location the value of the balance, that is array of balance and balance array value at 9th location will be going to the salary variable, that is also of double type. This says the above statement will take 10th element from the array and assign the value to the salary variable. Following is an example which shows will use the above mentioned 3 concepts, that is declaration, assignment and assessing. This is the example I have discussed. This is your initialization. This is your initialization. Then user access, and then how we can use it. This is declaration, assignment, and assessing. These are the examples, output of examples. Then we have discussed C array in detail. That is multiple types of C array. One of the type is it is a multi-dimensional array. Multi-dimensional array means when we are using more than one rows and more than one column, that is known as multi-dimensional arrays. Then next concept is your passing arrays to functions. Means whenever we use pointer, so that is done by passing arrays to the function. In the same way, we can return the array from the function. Then pointer to an array. Pointer is a variable that stores the address of another variable. So we can declare the array of pointer type also. Means int asterisk p then. That is p is an array variable that stores the address of integer type. Now we have also discussed what is pointer. A pointer is a variable whose values is the address of another value. Means who stores the value of who stores the address of the another variable. It does not store the value, but it stores the address of another variable. This is the how we can declare, that is type asterisk variable name. This is your pointer arithmetic, means how we can give the or adding the values in the pointer. We are not adding the values, but we are adding the reference. That is, we are adding the reference. That is your pointer arithmetic. So whenever we add anything in the pointer, so it is adding to the address, not to the value. For example, P is stored 1, 2, 3, 4, and the address are multiple different parts. So it will increment the address, not the values. This is your 2D array. Then we also discussed what is 2D array. That is your multi-dimensional array. That is more than one column and more than one rows. Here it is a declaration that is int my matrix. My matrix is the name of the array, and there are two square brackets. One is used for row, another one is used for column. So there are 3 rows, that is 0, 1, 2, and there are 4 columns, that is 0, 1, 2, 3. That is int my matrix 3, 4. Here there is a curly brace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is at 0, 1 location. That is my matrix 0, 1. That is your 2 value. That is my matrix 2, 3. This is your second row and third column. This is how we can generate, that is my matrix row and the column. Then we also discussed how it is physically stored within the array. So this is physically in one block of memory int my matrix 2, 4. That is 2 rows and 4 columns. That is row 1, row 2, and the 4 columns, that is column 1, column 2, column 3, column 4. This is first column, second, third, fourth. First, second, third, fourth. Then we also discussed 2D array names and their addresses. This is names. This is first point is 0 at first location, and this is the address, that is asterisk my matrix 1. That is the address of element, that is my matrix 1, 0. Then we also discussed how we can access the 2D array elements. This is int my matrix 2, 4. That is 2 rows and 4 columns. Then 1, 2, 3, 4, 5, 6, 7, 8. These are the 5, 8 numbers that starts from 1 and ending with the 8. Then we also discuss how we can declare the rows and how we can declare the columns. That is your predefined columns. In this, I have defined the rows as 3 and the columns as 5. So there are 3 rows, that is 0, 1, 2, 3. Sorry, 0, 1, 2, and 5 columns, that is 0, 1, 2, 3, 4. This is a declaration. This is int table rows and columns. So table is your array name, and there are rows and there are multiple columns, and return type is int. Then we use the function that is void display table. Then this is the definition of the void display table, that is void display int x rows columns. This is a curly braces start. Then there are 2 loops, that is your for loop and I think, yeah. There are two loops. That is, one is your rows loop and one is your columns loop. Uh, Till now we have covered in yesterday's class, but today I'm going to continue with the same slide, that is how we can access and how we can use the program. So let's start with the today's concept, today's topic with the same array name or the arrays. So let's discuss again the same topic, the same example which I have covered yesterday. This is 2D array often require nested loop. That is how we can use the 2D array and how we can use the nested loops. Nested loop means loop within the loop. So whenever we use 4 within the 4, that is your nested loop. So that is 2D arrays often require nested loop 2 variable. 2 variable means there are more than one variable or 2 variable, that is I and j. So we are using the nested loop using 2 variable, that is I and j. Then let's discuss the example. This is void display. Displays your array name. These are the arguments. There is a row, there is a column. We are using two for loops. One is for rows and one is for columns. This is int I equals to 0. I is a variable that stores value 0. Then I is less than rows. Means it will continue until the rows are over. Suppose I am giving 3 rows and 4 columns. This is an example. Suppose I am taking 2 rows and 3 columns. So it goes from 0, 1, it goes from 0, 1 and 2. So first of all this loop will execute, then only inner loop will execute. And if the inner loop will execute, first of all this will finish all the execution, then return back to the outer loop. So the condition is that, the point is that first of all inner loop, full inner loop, that is with full iterations until the condition is true. First of all inner loop will execute and then outer loop will execute. So first of all going from outer to inner, then inner loop fully execute with all the iterations until condition are true, and then going back to the last outer loop, that is your outer part. So this is int I equals to 0, that starts with 0. I is less than rows, that is less than rows. Suppose I am taking 2, this is 0 is less than 2, I plus plus. So this condition is true as I is 0 and rows are 2, 0 is less than 2, condition is true, go to the inner loop. Now j equals to 0, j has a value 0 and j is less than columns. I am taken column 3, so this is j is less than 3, that is 0 is less than 3, condition is true, then goes to the internal part. Print at the location 0 0, because there I is 0, I is value 0, j value 0, so print at the location 0 0, that is your first position. So this looks like this one. 2 rows and 3 columns. So this is the 0 0 location, that is your 0 0 location, right? So this will print over here. Then next part is your again curly brace. Now goes to the this part only, not goes to the outer part, only goes to the inner part. Now check the condition. J becomes now 1. This is 1. 1 is less than columns. Column is the same, that is 3. Now the condition is 1 is less than 0. Condition is true. Then go to this one. Now I has a value 0. I will not increment, but Z have increment. It will place at 0 1. This is 0 1. Then again goes to this curly brace. Again goes to this one. Now J become 2. 2 is less than 3. Condition is true. Again goes to an internal part. I have a value 0 and J have a value 2. Now again J plus plus. Again go to the inner loop. Now j is less than column, that is 3 is less than 3. It is not true, but 3 is less than or equals to 3. That is 3 is equals to 3, but not less than 3. So this will terminate. So this will not execute, and now it will not execute. So cursor comes over here. It will jump to the next line. So it will jump to the next line. This is used for next line. Now, with the use of this curly brace, again cursor goes to the outer loop. So the inner loop will terminate because the condition will not true or condition will fail. So goes to the outer loop. Now I has a value 1 because first of all I has a value 0, then I plus plus. Now I has a value 0. Sorry, I has a value 1. 1 is less than 2. Condition is true because the rows are 2. This is not 0. This is 1 is less than 2. Condition is true. Goes to the internal part. Now j equals to 0 because the inner loop will terminate. Now the j will start to the new value, that is j equals to 0. J is less than 3. Now same condition, 0 is less than 3. J plus plus, print ij. Now I has a value 1 and the j has a value 0. So this is placed at 0, 1, 0 location. This is 1, this is 0. Then again goes to the internal part. Check the condition. Now 1 is less than 3. Condition is true because j becomes 1. 1 is less than 3. Condition is true. I has a value 1. J has a value 1. So this will print at 1, 1 location. Again goes to this part. 2 is less than 3. Condition is true. Again goes to this part. I has a value 1 and j has a value 2. This is printed at 1, 2. Now again goes to this. 3 is less than 3. Condition is not true. This will terminate and goes to the next line. Now again move to the outer loop. Here condition is now I become 2. 2 is less than 2. So this will not execute. If this will not execute, it will not go to the inner loop. So loop will terminate over here. So here 2 rows are printed and 3 columns are printed. This is the way how we can use the rows and columns and how we can print the rows and columns of the nested loop. Then if this cursor, if this pointer will execute, then move to the next line and finish the code. So this is next, move to the next line and then finish the code. So this is how we can execute or how we can display the inner loop and the outer loop, that is nested loop. This is your table A, that is 13, 22, 9, 22, 23 and there is no value. In the same way 17, 5, 24, 31, 55, 4, 19, 29, 41, 61. In the same way one value is missing over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One is missing. These are the rows and the columns. This is the addition of matrix, how we can add the matrix. This is your addition of matrix. Now, next part is your declaration of statically allocated array. So till now we have discussed what is fixed size array. Now it's a time to discuss what is variable size array. This is clear. Fixed size array with the help of 2D array, that is your two-dimensional array. Now next part is your variable size arrays. This says only support multi-dimensional array where the sizes could be determined at compile times. Programmers requiring variable size array has to allocate storage for these arrays using the functions such as malloc and calloc. So arrays are generally used or mostly used for fixed size array, but for variable size array, C programming or any programmer or any programming language provides two functions, additional two functions, that is your malloc and calloc, that is used for storing the variable size array during the compile time. Compile time means during the time of execution. When the program is executing, then only the values will assign to the assign to the arrays. That is your runtime array, that is done by malloc or calloc. These are the codes for malloc, calloc. So this is declaration of statically allocated array. This says in C, an array is simply a fixed size aggregation of a list of cells, each of which can hold a single values. The number of cells in an array is known as dimensions. The number of values that are actually stored in an array is known as usage. This is your example, that is define buffer size 21, define dice sum 11. This is double array, that is X, that stores 1000 values. Then there is a character and there is an array, that is buffer. This is a buffer size. Then int dice frequency, dice sums plus 1. Then int num items equals to, that is number items equals to 10,000. Int list item equals to list num item. This is not valid. Num items is not a constant. This is integer variable. This is the declaration or comments by which you can understand the concept. This says the dimensions must start asterisk be a constant expression, that is at compile time. Now, what are the limitations of statically allocated array? That is at the static time, that is at the fixed time. What are the limitations? There is no way to alter the dimension of an array once it is declared. So there is no way or there is no method to declare or to alter the dimensions of the array once it is declared in the loop or once it is declared in the array. So there is no proper way or there is no proper format to alter the array, because that is done at static time and we are using the compile time, so there is no way to alter the dimensions or changing the rows and columns of the array. Then next point says access to individual cells using the same syntax as Java. However, there is no runtime check to be sure that the specified index is actually valid. So we can access the individual cells using the same syntax, but there is no runtime check as we done in the Java. There is no runtime check in the C language. Another one point says there is no automatic aggregate operations for array in C. This is not used. This not used. This is not used. Array cannot be accessed or passed by value to a function. Next is when an array is passed to a function, its dimension or usage must generally be passed as well. So arrays cannot be passed except the dimension and their usage. Now, this is your fixed size array. This is the time for studying the variable length array. This is in C, it is possible to declare an array whose dimension is not known as compile time. That is known as runtime. This is void f, that is your array. There are two variables. One is of simple variable, another one is for array variable. That is int main, int n, printf. Enter the size of the desired array. Then scan the value. So this is the syntax. First of all, we print the value. Then whenever user enters the value, so we can scan, or scan means we can access or we can store the values in the memory. Then int an, dimension is not known until runtime. This is an, this is the size that is given by the user. Then there is a function, that is f and a. Function n means the number of desired or the size of the array. A means, capital A means any value or the array element which is given over here. Then return 0. So this is the variable length array. Means this length or A can be declared or can be used at the runtime, not at the compile time, not at the execution time, but at the runtime execution. Now, next topic is your heterogeneous data structure. This is your new topic, that is how we can use the heterogeneous data structure. Till now we have covered the homogeneous data structure, that is of similar data structure, that is of similar type. Either I can take int, either I can take float, either I can take double, either I can take char. Means all the data are of similar data type, that is your homogeneous data structure. Now I am going to start with heterogeneous data structure, that is how we can use the different data structures of different values. Suppose I am using int, that is of one value is of int, another value is of double, another value is of char, another value is of long. So I am using multiple data types, that is your heterogeneous data structure. So this says C provides two mechanisms for creating data types by combining objects of different types, that is structure. So C provides two mechanisms or two methods for declaring the heterogeneous data types by combining objects of different types. Different types means one is int, one is double, one is float. That is known as structures, that is declared using the keyword struct. So this is the user defined data type. Till now we have covered int, float, double, that are predefined. But now it is declared using the keyword struct, that is your user defined data type, that is struct. Aggregate multiple objects into the single unit, means combining the multiple results into the single unit, that is union, declare using the keyword union. Allows an object to be referenced using several different types. There are two mechanisms for using the homogeneous data structure, that is structures and array. Now let's discuss one by one what is structure and what is union. All are both are same concept, but only one difference. That difference I will tell you at the end. But both are used for heterogeneous data type, heterogeneous data structure, and both are used as user-defined data types. Now let's see in your book. These are the multiple examples. Now this is heterogeneous data structure. This is the same paragraph. Now let's start with the structures. This says the C struct declaration creates a data type that groups, means that combines objects of possibly different types into a single object. As I told you, it can combine, or structure can combine or group multiple objects of different types into the single object. Multiple types means group, multiple groups means, or multiple objects means more than one object, or the more than one object of the different types. Different types mean one may be int, one may be double, one may be float, into a single object, into a single group. That is your structure, and the keyword is a struct, and it is a user-defined data type. This says C programming provides as a ability So C programming language, which has the ability to divide the data into different types. The type of variable determines the what kind of value, means what type of value it may take on. The various data types are simple, that is your int, real, void, char. Next one is a structured, that is your array. We have discussed string. One is your user-defined data type, that is structure, union, and enum, that is enumerators. But today I am going to discuss with only two user-defined data types, that is structure and unions. This says a structure is a user-defined data type that is used A structure is a user-defined data type that groups logically related data items of different data types into a single unit. So this is used to group logically related data items. Related data items means which are related with each other of different types. One is of int, one is of char, one is of double into a single unit. Single unit means a single whole unit, that is array 1 or the array A. That is a single unit, and that contains multiple or different data types values like int, char, float, double. All the elements of a structure are stored at contiguous memory locations. A variable of structure type can store multiple data items of different data types. As I told you, under the one name, as a data of employee in company, that is name, employee ID, salary, address, phone number is stored in structure data structure or structure data type, because name is of string, employee ID is of numeric, salary is of numeric, address is of alphanumeric. So this is your integer, this is also integer, this is also integer, this is not integer, that is your float or double, then phone number is also integer, and this is not integer name, it is a string, because string is a collection of characters. So we can use the name as a string or character. Next, how to define the structures. Defining of structure means what is the layout or what is the syntax for structure. This says a structure has to be defined before it can be used. The syntax for defining a structure is struct. This is a keyword, that is your struct, struct. Then there is a structure name. Suppose I am using structure A, so I am using struct A. Then there is a data type, that is your int, float, double. There is a variable name. Suppose int B, that is your variable B. Variable name is B, and the data type is int. Then double C. So C is a variable, and the data type is double. In the same way, we can declare multiple data types or multiple variables of different data types, and then close the curly braces and then terminate with a semicolon. This is how we can start. First of all, start with a struct, that is struct. There is a structure name, then declaring the variables of different data types, that is data type, variable name, data type, variable name, and so on till last one. Then curly brace close and then terminate with a semicolon. This is your mandatory condition, that it structure always terminate with a semicolon. This is the example of employee, structure of employee, that is declared as struct employee. Struct employee means this is a keyword and this is the structure name. So this is your keyword and this is your structure name, that is your employee. Then curly brace start, that uses one variable, that is employee ID, as int, because employee ID is of int type, so uses employee ID as int. The name 20, that is it contains 20 characters, that is from 0 to 19. So it contains 20 characters, that is of data type char. Then there is another variable that is of type float, that is salary is of type float. Then there is the address, that is of 50 characters, that is from 0 to 40, and that is of type char. Char means a character value, that is from 0 to 49. Then there is a department number, that is of type int. That one is age, that is also of type int. So you can see these are the multiple different data types: int, char, float, char, int. So this is a heterogeneous data structure that is provided by the structure. Then curly brace close and then terminate with the semicolon. So it always terminates with the semicolon. This is the memory location, how we can store the structure within the memory. First one is your employee ID. This is stored at 8000. As I told you, it takes how many bytes? 2 bytes. This takes 2 bytes, that is from 8000 to 8002. This is a difference of 2 bytes. Then name 20. There are 20 characters and the char takes 1 byte each. So this is 20 characters, or from 0 to 19. So this takes 20 bytes. 20 bytes means because 20, because these there are 20 values, and each value and each number contains or takes only 1 byte. That is from 2 to 20, that is from 22. That this is the difference of 20 characters. Understand, char takes 1 byte. This is of 20 string, 20 characters. So these are the 20 elements or 20 increment of memory. Then there is a salary, that is a float type, and the float takes how many bytes? 2 bytes. So this is from salary to 22 to 24. Then there is a next one, that is of address. This takes 50. Address is of characters. So this is from 24 to 74. Then there is a department number, that is also taking 2 bytes, 74 to 76. Age is of integer type, that takes also 2 bytes, that is from 76 to 78. So this is the how we can store in the memory location, that is from 8000 to 8078. Then how to declare the structure variable. Till now we have discussed how to declare the structure. Now next is your how to declare the structure variable. Means once finished defining the structure, for example structure employee. Now using the variable or declaring the variables of the structure so that we can access the values of the structure by using the variable. That says a structure has to be declared after the body of the structure is defined. So a structure has to be declared after the body of the structure is defined. The syntax of the structure of declaring the structure is struct name, means how we can declare the variables. First of all use struct keyword, then structure name. For example employee, and there is a gap and there is a variable name. So first of all struct, that is struct, then there is a structure name, for example employee. Suppose I am declaring the variable of employee as E1, so struct employee E1, comma E2, comma E3. So struct is your keyword and the employee is your structure name and the variable names are E1, E2, E3 and so on. This is the examples to declare the variable for the defined structure employee are struct same employee and then E1. E1 means the variable of the or the name of the variable of the type struct. That is your struct, structure name, variable name. Here E1 big variable contains 6 members that are defined in the structure. So this says E1 is a variable of structure type that contains 6 members that are defined in the structure. Now this is your declaration, this is your initialization, means how we can initialize the structure elements. This says the members of the individual structure variable is initialized one by one in a single statement. The example to initialize a structure variable is how to initialize struct employee E1. E1 is a variable that have a value 1. 1 is the employee ID, then name, then salary, then address. This is name, this is salary, this is address. 3 Vikas Colony, New Delhi. Then there is a department number and then there is a age. This is your department number 10 and age is 35. So this says E1.employee ID. How we can initialize, how we can access using the dot operator. This is E1.employee ID equals to 1. Second, E1.name equals to Hemant. E1.salary equals to 12,000. E1.address equals to 3 Vikas Colony, New Delhi. E1.department equals department number equals to 1. This is not 1, this is your 10. E1.age equals to 35. This is misprinting, this is 10 because the employee ID is 1 but the department number is 10. So here 0 comes, that is 10 and the age is 35. This is how we can initialize the structure element. Now how to access the structure element? The structure element cannot be directly accessed in the expression. Means they are not directly accessed like I am accessing the .e1 or e1 as a variable. No, they are not accessed directly, but they are using or they are accessed using the dot operator and the arrow operators. They are accessed by using the name of the structure variable followed by a date and the name of the member variable, like this one. First of all, the name of the structure variable, that is E1 followed by a dot, then there is a dot and then the name of the member variable which I want to access. That is your employee ID, name, salary, address, phone number, department number, anything, whatever you give in the program. So how we can access or how we can access the structure member? First of all, there is a variable name. Which variable name? Structure variable name. then there is a dot operator, and then there is a name of the structure or name of the member variable. For example, e dot, even dot, employee ID, even dot name, and so on till even dot age. The data within the structure is stored and printed by this method using scanf and printf in the C language. So this is accessed by using the printf statement that is used in the C language. Then how we can assign the structure elements? It is also possible to assign the structure elements. This says the value of one structure variable is assigned to another variable of same type using assignment statement. Assignment statement is equals to. This is your assignment statement. For example, if the E1 and E2 are structure variables of type employee, then the statement E1 equals to E2. This says E1 and E2 are structure variable of the type employee. These are of the same type, that is your employee. If I want to assign the values, E1 equals to E2, that is E2 values is going to the E1 value. This is your destination and this is your source. So source always comes at the right side and the destination comes at the left side. This says it assigns value of structure variable E2 to E1. E2 to E1. The value of each member of E2 is assigned to corresponding member of E1. Suppose there are 5 elements A, B, C, D, and there are 5 elements in E2. In E1, A, B, C, D, E. In E2, there are 5 elements W, X, Y, Z, A. So these are assigned. A is assigned to W, B is assigned to X, C is assigned to Y, D is assigned to Z, and E is assigned to A. How we can assign? Member by member. Every member of E1 is assigned to every member of E2. That is our corresponding members. Now, there is a program how we can implement the structure in C language. This is program to implement the structure. That is hash include stdio.h, that is hash include conio.h. This is standard input output header file. This is common input output header file. Then there is a struct. This is your struct employee curly brace start int employee ID. This is your keyword and this is your structure name. This is your struct and this is your structure name. Then curly brace start. Then it starts with the int employee ID, that is int employee ID char name 20. It is of 20 character from 0 to 19. Float salary, char address 50, int department number, int age, and then curly brace close and then terminate with a semicolon. This is the way how we can declare the structure. Then using the void way, using the variable of different structure types. Employee is the structure name, so uses struct employee E1 comma E2. That is using the keyword struct and there is a variable name that is employee and declare there is a structure name employee and declaring the two variables that is E1 and E2 of the structure variable that is employee. This is printf, enter the employee ID of employee. This is used for taking the input or displaying the same line on the screen. Then scan means putting into the memory, that is %d ampersand. This is ampersand E1 dot employee ID. Means the employee ID which is provided by the user is stored in the structure variable that is E1 and stored in the memory. So it is accessed using the structure variable that is E1 and dot operator is used for accessing the values. And these are stored by using this operator that is your ampersand or address of operators. Next line is printf, enter the name of employee. Because this is of int type, I am using %d. As this is of character type, this is a string. String is collection of characters, so I am using %s. So whenever there is a int, this is of percentage %d. Whenever there is a character string, there is a percentage %s. Then printf, enter the salary. This is a float, so using percentage %f. Then even dot salary. Then address. This is of character, so using percentage %s. Then department. Then percentage %d because it is of int type. Then age. This is of d, int type. Employee ID. I am using now another variable. Till now I have covered E1, now I am using E2. Same concept, E2, E2, E2. Then print. Now it's a time for printing. The employee ID, this is used for scanning, age, name, address, department, salary. Now the printf, the employee ID of employee is percentage %d because I am using int. So using or print the values by using E1.employee ID, that is accessing the values using the dot operator and the structure variable, that is E1. Second, printf, the name of the employee is E1.name. So how we can access by using the E1. Then salary, E1.salary, that is using the percentage %f because it is of float type. Then there is the address, that is percentage %s because it is of string type, that is percentage %s E1.address. Then there is a department number, it is of int type, so this is E1.department number and using percentage %d. Then the age, it is also of int type, so using percentage %d and using dot operator, that is E1.age. So the main concept is that whenever we use structure variable, whenever we use structure, so how we can access using the dot operator, that is E1.department number, E1.address, E1.salary. And whenever we use int, so the specifier is percentage %d. If I am using float, the specifier is f. If I am using string, that is number of characters, then the specifier is percentage %s. In the same way, we can display using the E2 structure variable, that is E2.employee ID, E2.name, E2.salary, E2.address, E2.department number, E2.age. Then using getch, that is used for printing the output, that is getch, then curly brace, semicolon. This is stored in the header file, that is conio.h, common input output.h, and this is getch used for displaying or printing the output. Then there is a closing of curly braces. These are the output of the program. First of all, employee ID of employee is 1, Rahul, 15,000, address, department, age. Now employee ID of employee, this is another employee. 2, Rajiv, 14,500, this is your address, this is your department number, and then there is the age. This is the output, how we can access and how we can use the array by using the structures, or how we can use the structures in C language. So let's take first of all 5 to 10 minutes break and then come back and then start with another topic, that is your array of structure. Means how we can use the array in the structure. Means how we can give multiple names, multiple values in the structure. So let's take 5 to 10 minutes break, come back, start with the array of structure. Now let's start with next topic, that is your array of structures. Means I am using array within the structure to declare the array variables, to defining the variable of the arrays, or for defining the variables of the structures using the arrays. So this is C language also allows to create an array of variable of structure. That is, it allows to create an array of variable of structure. The array of structure is used to store the large number of similar records. Means how we can use the array? We can use the array of structures, means the combination of structure that is used to store the large number of similar records. Similar records means because array is of similar type, so it is used to store the large number of similar records. For example, to store the record of 100 employees, Till now we have covered only two employees, that is E1 and E2. And if we want to store the records of 100 employees, then array of structures is used. The method to define and access the array elements of array of structure is similar to other array. That is very similar as we discussed in the last class how to declare the array. This says the syntax to define the array. The syntax to define the array of structure is same, using the struct keyword. Then there is a structure name, there is a variable name like E1, E2, then array name and the value. In the square bracket there is a value like 10, 20, 30, means the array elements. If there is a 30 value, that is from 0 to 29. If there is a 20 value, that is from 0 to 20. This is the program to implement the array of structure, that is hash include stdio.h, hash include conio.h. There is a declaration of the structure, that is struct employee. Same example, int employee ID, char name 20, float salary, int char address, int department number, int age, and then curly braces close, there is a semicolon. Then void main struct employee E1 5. Till now we have covered only one employee, that is E1. Now E1 has a 5 values, that is there are 5 employees named E1. Now using the loop, that is for loop, declaring the value of the variable I is the variable that stores some value, so it is int I. Then for I equals to 1, I is less than equals to 100, I plus plus. So this goes from 1 till 100. This also includes 100 and starts with the 1. There are total 100 values. Then there is the I plus plus. Then curly brace start, printf, enter the employee ID of the employee. Employee ID of the employee, and that is of 5 employees. So I am using array variable or array for scanning the values, for storing the values to the memory. This is %d, ampersand ei. First of all, it takes at one location when I is 1, when I is 2, this is second location, when I is 3, this is third location, fourth location, and then fifth location till the condition is true. This is from 1 to 100. So this takes the 100 values, and this can be accessed by using the dot operator. This is ampersand ei dot employee ID. Then next line says printf, enter the name of employee. Now this is used for defining or for entering the name of the employee, that is scanf %s ei dot name. This is ei means first of all 0, 1, 2, 3, 4 till 100 points. Then E1 dot name. Then enter the salary of the employee. This is your salary. Enter the salary of the employee. Then scanf the salary, that is %ei dot salary. Then enter the address in the same way. This is the string, so I am using %s, then ei dot address. Then there is a department number, department, so I am using ei dot department number, age. Then scan means scan all the values, all the records that a structure employee contains, like department number, address, age. Then for I equals to 100, I is less than equals to 100. Again using the same loop, starting with the 1, ending with the 100. That is from 1 to 100, I plus plus, printf or print the value. The employee ID of employee is E1 dot employee ID. That is EI. First of all, this is 1. So this will print only one value. Then 2, 3, 4 till 1 to 100. Then in next line, the name of the employee, that is ei dot name, salary, that is ei dot salary, ei dot address, ei dot department number, ei dot age. So this is how we can use or how we can give the print command for printing the values like salary, address, department, age, employee ID, name. Then there is a get ch for displaying the output. Now, structure within the structure. This is your next topic. Till now we have covered structure, array within the structure. Now, this is the time to use structure within the structure, that is nested structure. This says C language also provides or define a variable of structure type as a member of other structure type. So it's a provision to define a variable of the structure type in the another variable type or in the another type that is also a structure. The syntax to define the structure is struct name, this is your structure, data type, curly brace start, data type, variable name, again using struct name. So this is the inner struct, that is a inner struct of the outer struct. This is your outer struct, this is your inner struct, that is struct name, data type, variable name, struct name, data type, variable name. Then give how as much you can data type and the variable name like int a, float b, char c. Then close the structure variable, data type and the variable name. Then close the curly brace and then there is a semicolon. Now example, I am using same example, struct employee, int employee ID, char name 20, float salary, int department number. Then in this employee struct I am using struct that is date, and date contains 3 parts. This structure contains 3 parts. One is day, that is from 1 to 31, then month, that is from 1 to 12, then year may be any year in 4 figures, that is 2010, 2001, then curly brace close for this one, date. Then there is a variable that is doj. This is the variable of the date. So this is another method how we can declare the variable. That is after using the curly brace, give the name of the variable, that is doj, that is date of joining. Then end with the curly brace. So this is the closing of this structure. Now this is the closing of the main structure, that is employee. I am repeating again, I am using struct employee and these are the multiple variables of different data types. I am using another struct that is within the employee, that is date, that contains 3 parts or that stores 3 variables, day, month, year. Day contains the numbers from 1 to 31, month contains numbers from 1 to 12, year contains a number in 4-digit format, that is 2000, 2001, 2, 3. And I have declared date variable or the structured date variable at doj, that is date of joining. This is, and then close the curly brace or close the structured date by using the semicolon. Then the main structure will terminate or close by using the semicolon. Now, how we can access structure within the structure? This is how we can declare. This is how we can access by using the 2-period dot operator. This is your 2-period dot operator. The syntax is struct variable dot nested struct variable dot struct member. So first of all, I am using struct variable, then there is a dot operator, then there is a nested struct variable, then there is a struct member. So this is, for example, even.doj. As I told you, I am using the variable doj of the date struct type. So this is even.doj, that is date of joining dot day. Then even.doj dot month, even.doj dot year. So this is used for using the 2 dot operators. One is used for outer structure, another one is used for inner structure, that is even is your outer structure variable, then doj is your inner structure variable, that is date structure variable, and then using the variable name, that is day, month, year. So this is how we can use the structure within structure. Next, is your pointers and structures. Now, as I told you in the last class, pointer is a variable that stores the address of another variable. So, I am using pointers within the structure, that is pointers and structure. This paragraph says, C language can define a pointer variable of structure type. Means we can define the variable, or we can define the structure of the pointer variable of a structure type. The pointer variable to the structure variable is declared by using the same syntax to define a pointer variable of data type. This is same as we declare the pointer by using the star operator, by using the asterisk operator. The syntax to define the pointer to structure is struct name. First of all, use struct, then there is a struct name, then there is a difference operator or asterisk, then there is a pointer variable name. For example, I am using same struct employee. This is the same structure or the same structure that is defined, that is employee. Then there is a pointer variable that is emp. This is the asterisk emp. This says it declares a pointer variable emp of employee type. So this is how we can declare by using the same struct is a keyword, then there is a structure name that is employee, and then there is a asterisk that is asterisk emp. So it declares a pointer variable emp of the type employee type. Now how we can access? Till now we have covered how we can access by using the dot operator and by using the double dot operator. Now how we can access the pointers in the structure by using the arrow operators. This is the member of structure variable is accessed by using the pointer variable with the arrow operator. This is the arrow operator instead of using the dot operator. The syntax is same, pointer variable name, for example emp arrow structure member, for example emp arrow name. Name is the structure member, as are defined name, address, these are the members of the structure. So here name structure member is accessed through pointer variable emp. Now how we can pass structure to a function? This can be, the structure variable can be passed to a function as a parameter. So the structure variable means the variable of the structure can be passed, or is we are able to pass a structure variable to a function as a parameter. Parameter means that is we are giving the arguments. The program to pass a structure variable to a function is, how we can write the program? This is the program. Hash include stdio.h, conio.h, struct employee, int employee id, char name 20, that is employee id is of int variable, that is of numeric digits, then name 20, that is of name is of 20 characters, that is from 0 to 19, then there is a salary that is of float, that is a decimal, then close the curly brace. Now using void main struct employee E1, printf enter the employee ID of the employee, then scanf ampersand E1 dot employee ID. So this is how we can access by using the dot operator E1 dot employee ID, in the same way name, in the same way salary. Now using the function, this is your main concept. How we can pass? We can pass by giving the name of the function, that is print data, then struct, this is the structure variable employee E1. So this is how we can define the function, that is print data, struct employee E1, then get ch. Then there is a curly brace dot. Now this is the definition of the print data. Void print data struct employee emp. I am defining the print data and the name and the arguments are struct employee. As I told you, these are given as the arguments or the parameter. So this is void print data struct employee emp. Then there is a printf. The employee ID of the employee is %d emp.emp ID. So now I am using emp as a parameter and using the dot operator to access the employee ID. In the same way, uses the dot operator to fetch the name, to fetch the salary. This is how we can pass. This is the method for passing the function or the passing the arrays to the or structure to the function. This is how we can pass. This is the syntax how we can pass the arguments. Then function returning structures means how the function returns the structure. The function can also return a variable. The function can also return a variable of structured type like an integer and float variable. So struct also defines or gives a value or returns a variable of different types like integer, float. The program to return a structure from function is, what is the program? Hash include stdio.h, conio.h, struct employee, employee ID, name 20, float salary, same step. Using struct employee emp means declaring the variable of the structure that is employee as emp. Now get the data or store the data of the get data function to the emp. Emp is the name of the structure variable. So store the value that is returned by the get data. Get data is a function that gives some value or that returns some value that is stored into the emp, that is employee or emp. Then printf, the employee ID of the employee is emp.empid. In the same way emp.name, in the same way emp.salary. So this is how we can access the data, that is get data. Now this is a definition for get data, that is struct employee get data, struct employee E1, printf. This is the another variable that is used, E1, printf, enter the employee ID of the employee. Then scanf, E1.employee ID, in the same way E1.name, E1.salary. Then returns the value E1. So whatever the value returns, that goes to the this one, it's your emp. This is how we can function or how the function returns the structure variable. So till now we have covered the structure. This is your heterogeneous data type. Now the next part that is similar to the structure, that is your union data type or union data structure. So this says union data type. A union is also a user-defined data type like a structure. But what is the main difference? The union group logically related variable into a single unit. Related variable means that are of different types like int, float, double, long. That is of different types that stores the values or the variable into a single unit. Means into a one unit. The union data type allocates the space equals to the space needed to hold the largest number of unions. This is the main difference. The main difference is that in structure, the allocation of the different methods or different elements of the structure are allocated differently to the memory, depending on the size. Like int takes 2 bytes, the memory is of 2 bytes. Float takes 4 bytes, memory is of 4 bytes. But union allocates the largest amount of memory. Suppose I am using int, float, double. The highest one is double, it takes 8 bytes. So the memory, so the location or the memory is of 8 bytes. That includes int as well as the float as well as the double. But on the other hand, structure uses different memory for int, different memory for double, different memory for float. So this says the union data type allocates the space equals to the space needed to hold the largest data member of the union. Largest means example double. The union allows different types of variable to share same space in the memory. There is no other difference between structure and union. This is the main difference. Union takes the largest value or the largest data type and stores the other variable in that type. But in structure, memory location or the memory is allocated to each and individual data element. The method to declare, use and access the union is same as a structure. Like I am using access operator, how we can access using the dot operator. When we are using pointer, how we can access using the arrow operators. So all the methods, return name, function definition, all the methods is same as of the structure in union. There is no difference. Now, how to define? A union has to be defined before it can use, like in the same way we did in the structures. The syntax for defining a structure is, what is the difference? Define union name. Means first of all using the keyword union. In that we uses the keyword struct. In this we uses the keyword union. Then there is a union name. Union name means any name of the union, like employee. So union employee, then curly brace start, then starts with the data type. First one is your data type, then there is a variable name. Then data type, variable name, and so you can store or you can maximize or you can give as much as of you data type and the variable name. Then there is a curly braces, then there is a semicolon. So this is how we can declare the union. Example of employee is the same. Instead of struct, I am using union. This is union employee, employee ID, name, salary, address, department number, age. Then curly brace stop. This is your how we can enter the memory. Address is of 50 bytes. This is the highest one. So whole unit, whole memory is of 50 bytes, and we can store the data within the 50 bytes. This is of 50 bytes. We can store employee ID, department number, age between this one, name between this one, address between this one, and the department number or the address within this one. This is how we can allocate the space to the memory. Then, what is the difference between structure and union? Now, the memory occupied by the structure variable is the sum of the sizes of all the members. Means it is the memory that is occupied by the structure is the addition of the sizes or addition of the chunks of the multiple members. But memory occupied by the union variable is equal to space held by the largest data member of a union. So in structure, it is the sum of the different sizes of different members, but memory occupied by union is equal to the space held by the largest data member of a union. That is your largest means the highest value of the data member of a union. Then second point or the second difference is that in the structure all the members are accessed at any point of time. Means we can access using the dot operator, arrow operator, but in union only one of the union member can be accessed at any given time. Means we can access only one member like employee ID, department number, name at the same time, but in structure we can declare more than one item or all the items within at the same time. So this is the main difference. Next, what are the applications of or the application of structures or union? Because both are the same concept. So what are the application, how we can use and where we can use? This says structure is used in database management system to maintain data about books in library, items in store, employees in an organization, financial accounting transaction in company, and so on. So structures are used in database management to maintain data about books. Whenever we have to maintain the data or maintain the books in the library, so we can use the structures. In the same way, we can maintain or store the items. We can also maintain the employees in our organization like employee ID, department number, that is done by the structure. Besides that, other applications are how we can access changing the size of the cursor. Means what are the applications or what are the places where we can use the structure. But whenever we have to change the size of the cursor, whenever we have to clear the contents of the screen, we use the structure. Draw any graphics, shapes on the screen, receiving the key from the keyboard, placing the cursor at the defined position, checking the memory size of the computer, finding out the list of equipment like input and output device that is attached to the computer, hiding a file, sending the output to the printer, interacting with the mouse, and formatting the floppy. These are the multiple applications where we can use the structure and the unions. Now, there is a summary points what we have covered in the today's class, that is in structure and union. First point says a structure is a user-defined data type that groups logically related data items of different data types. Logically related means all are related, like employee ID, department number, all are related with each other, but are of different data types. One is of int, one is of char, one is of float, one is of double into a single unit. Second point says the elements of a structure are stored at the contiguous memory location. Contiguous means one after the another. Then next point says the value of a structure variable is assigned to another variable of same type. Means we can assign the value of the structure variable to the another variable, but the condition is that that must be of same time using the assignment operator. What is the assignment operator? That is equals to. Next point says an array of variables of structure is created. Means we can also create or we can also use the array of the structure or the combination of the values. Then next point says a variable of structure type is defined as a member of other structure type called nested structure. Means we can use or we can combine or we can give structure within the structure, that is your nested structure. That is, we can define structure within the structure. Then the member of structure variable is accessed by pointer variable. So whenever we use pointer variable, that can be accessed by using the arrow operator. And whenever we use the simple structure variable and access the element, that is done by the dot operator. So dot operator is used for normal structure variable and the arrow operator is used for pointer variables. Then next is the structure variable can be passed to a function as a parameter. Then next point says the function can return a variable of structure type. Means the function or we can return the function values as a structure type. Then next point says union. A union is like a structure. It is similar to the structure that groups logically related variables into a single unit. But the union allocates the same space equal to the space needed to hold the largest data element. Suppose there are 4 elements, so it is used to store the or hold the largest data element of the unit. Then at last says structures are used or structure is used in database management. This is the application. It is used in database management and many more applications of the database. So this is what is known as heterogeneous data structure. So thank you very much. If you have any doubt, so please text the doubt and I will answer you. But before that, let's take a quick review of your book as well as what we have covered in the today's class. This is your book, this is your structure. These are the examples of structure. Struct rectangle, this is length, lower left coordinate, lower left corner, y coordinate. This is the example. Another example, this is how we can store the data, which I show you. This is the way how we can declare. These are the multiple examples of structure definition. Then there is a union, how we can use the union. This says union provides a way to circumvent the type system of C, allowing a single object to be referenced according to the multiple types. That is, only one reference of single object can be used, that is used as a largest number, or that is used to store the largest number. The syntax is the same as compared to the union. This is the union U3, char C, I2, double B. These are the multiple examples of structure and union. Then there is the next data alignment, means how we can align the data, as I told you, by using the equals to operator. These are the multiple examples. Next is your putting it together, understanding pointer. This is our next class topic, that is tomorrow's class topic, how we can use the pointers in C language. Now let's take a quick review of the today's class, what we have covered in the today's class. I have started with your 2D array, means how we can use the 2D array in C language. This is the example we have discussed of the matrix, that is rows and columns. Then we also covered this example. Then we have covered how we can allocate the array elements statically and array element at the dynamically, that is at runtime location. This is variable length array. Then we have talked about the heterogeneous data type, means using different data types like int, float, char, double in the data structure in the C language. So this is done by using two concepts, that is structure and union. So structure and union, there are two concepts. One is there are multiple data types, simple data type, structured, user defined. This is a structured data type. Then we have covered how we can define the structure. Then what is the example of the structure or example of structure. This is how we can route the memory allocated to the structure. This is how we can declare the structure variable, that is after the structure name. Then how we can initialize the structure members, how we can access the structure members, how we can assign the structure to the another structure, that is E1 to E2 to E1. Then what is the program or the program to implement the structure. Then this is also a program, we are using two variables, that is E1 and E2. Then these are the multiple outputs of the program. Then array of structures, means we are using more than one variable, more than one values of the structure variable, that is we are using array within the structure. This is a program, this is the array concept. I am using 20 characters, that is from 0 to 19. Address is of 50 characters, that is from 0 to 59. Next, what is the program to implement the array of structure. Then structures within the structures, that is nested structures, means we are using the structures within the structure. There is one structure and I am defining another structure within that structure. This is the syntax we have covered. This is the example. Date is the structure that is covered under the structure, that is employee. Now next we have discussed how we can access the structure within the structure using the two dot operators. Next we have also covered how we can use the pointers within the structure or pointer and the structures. And how we can access the pointer elements in the structure by using the arrow operators. Then we also covered how we can pass the structure to a function. This is how we can pass the structure to a function, and how we can return the structure as a function's output. Then we have also covered what is next data type that is used for heterogeneous, that is union data type. This is the same as a structure, but the main difference is that in structure, every element, every variable takes different memory location. But in union, there is a largest number, there is a one memory location that is of largest number, and all the variables uses the same memory location while for using or for declaring or for accessing the values in the structure. Then we have covered how to define the union. This is the example of the union. These are the memory concepts or the memory allocation of the union. Next, we also covered most important topic, what is the difference between structure and union, what are the applications of structure that is used in database and other many applications. Then we have covered what is the summary or what we have covered in structure and union. These are the multiple important points. So that's all for today's session. Thank you everyone. Now, if you have any doubt, then please text the doubt and I will answer you. And in tomorrow's class, I will discuss pointers and the GDB debugger, means how we can debug the errors and how we can use the pointers in the C language. So that's all for everyone. Thank you so much. We will meet tomorrow. Bye-bye.